Hey guys, this is Dan. I'm going to be going over my forces and motion unit plan. So let's get started. So here we have the home page. Um, and on the home page, I have a summary of the forces and motion unit, and I have the big ideas. Just a quick overview. This is a physics unit for juniors and seniors in high school, and it's going to focus on forces and motion, if that wasn't already obvious. The big idea, the questions that I want students to be thinking about as they go through this unit are, can we predict the forces around us? Can we predict what will happen in a collision of two bodies? And if so, how well? And can we use our knowledge of collisions and forces to minimize or negate damage done to bodies resulting from the collision? And how difficult is this? So as I go over this unit, just keep in mind those questions. So we're going to start with the teacher's page. And over here on the teacher's page, I have listed the student learning objectives. And I also have listed the California Content Standards for science. And you can see here if you read through the two standards, HSPS 2.1 and HSPS 2.3. So the first standard is analyze data to support the claim that Newton's second law of motion describes the mathematical relationship among the net force on a macroscopic object, its mass, and its acceleration. And also use mathematical representations to support the claim that the total momentum of a system of objects is conserved when there's no net force on the system. And then the second standard is to apply scientific and engineering ideas to design, evaluate, and redefine a device that minimizes the force on a macroscopic object during collision. So those are the 2 or 3 things that I want students, or that students hopefully will be able to do after this unit. And we also have the student learning objectives. So students should be able to identify forces on two bodies leading up to a collision, during a collision, and after a collision. They should be able to draw force diagrams, and the list goes on. And you can read through that. So let's start then with lesson 1. Okay, so the first lesson I have is a force and momentum lecture. So right here I have just kind of a worksheet that would be passed out with this lecture, and below it I have a link, or I have my PowerPoint slides for this lecture, and we can just kind of click through and see what these are. So you can see I start off with the 2 or 3 big questions, which is, what is a force, what is a momentum, and what are some times you came across these concepts in your life. So though I just like to lead this off with 3 questions that I can get the students thinking about before I get started with this lecture. So okay, I start off with what is a force. So I kind of have just a conceptual definition here, and then I also have a more technical mathematical definition. So I did break down forces into 2, contact forces and fundamental forces. And then I go on to Newton's second law, which is kind of the crux of this whole unit, which is F is equal to ma, force is equal to mass times acceleration. And here is kind of where I like to ask the students, does this make sense? Do we understand what's going on right here? And I like to bring up the point that some of these words that we use in physics have different meanings than when we're using them in our day-to-day lives. And so I just like to make sure that kind of everyone's on the same page here. And then we do something kind of a little fun, a little demonstration, where I challenge a student to pull a rope perfectly tight with a weight on the end. And they quickly will find out that it's impossible, and I kind of ask them why. Why can't it be pulled perfectly straight? And I give them a little hint here. Is the force a scalar or a vector? And we'll go on into momentum. And I have a Bill Nye clip here that's just kind of quick, and I can play a little bit of it. And it's just one where he is showing why, or is explaining why a bowling ball can knock down pins, but a ping pong ball can't. And then I go into some more math here, and again I give a mathematical answer to how force and momentum are related, and I give a conceptual answer. And then I do a quick review, and that is the end of lesson 1. Okay, on to lesson 2. So actually lesson 2 is a web quest, and you can see I have linked the web quest. So this web quest is the collision crash course. So you can see here, in this collision crash course, you will explore the physics behind collisions. So the students will be doing a little research on their own through the web. We can just quickly go over this. Okay, it's a little laggy. Okay, introduction. So collisions are an exciting part of physics. They can be dangerous, as in car crashes. They can be fun, like playing pool, and they can really be just about anything. But what's really going on behind the scenes? And this is just kind of to get students a little interested, a little excited. So again, here's the task. Okay, so the process. So I have here, just in the beginning, a link to Khan Academy, a Khan Academy video about momentum. This is a really great video where he gives this example of 2 pool balls that collide with each other. So this would be kind of like just more of a traditional questions, like what is the final velocity of ball B? Is the momentum conserved? What is so I have students answer those questions, and then I move on to something a little more fun, where they can simulate and record car crashes using the site that I provide them here. And as you guys can see, this is kind of just kind of a fun site where they can set up, what's the starting velocity? Like, let's say 30. Oh, this car's going real fast. They can ram it in and get a little visual as well as numerical representation of how much damage this car took. And you can see that you can set different, you have 4 inputs that you can set, and then you can see kind of what you get back. And if you play around, you kind of realize that, well, why don't I just max out this stiffness here? And let's just set it down here, and let's see what happens, right? So we have this huge deceleration, right? So if we have something less stiff, the max deceleration is actually less. So that's kind of, yeah, and you kind of get a sense for these things as you play around with this car crash simulator that you might not know had you not been able to just fool around with it. And I do give some questions here. I think the most important question in this is, how do the inputs have to do with the outputs? And I said to use at least one graph or diagram in their answer to clarify it. And then I move kind of into the main project of this unit, which is going to be an egg drop. So I give them a link to an egg drop simulator. And this is just like a little larger here. So they can set, some of the conditions. Do they want a jumbo egg? How high do they want to drop it from? And what do they want it landing on? And this is pretty straightforward. If you drop it on, foam from 1 meter, it'll be fine. and it tells you some of the numbers, the change in velocity, the impact. So it just gives them just an idea of some of the forces that are going to be on this egg and what to think about when they're building their project. And so the final question here, as you can see, is combine the ideas from the car crash and the egg drop simulator to create your own contraption to protect the eggs as it drops. So I kind of outline, like, get an egg, record its mass. I tell them the heights we're going to be dropping it from, and I tell them to calculate the potential energy. Then here's the crux: plan your contraption. So I ask them to think about what really is making the egg break. What variables can they control? Can they reuse their contraption? And is it feasible economically? We're trying to build with stuff that's around the house. And then I have the evaluation and the conclusion. Let's see here as it loads. There we go. So here I have this evaluation rubric. You can see that it's mostly effort and completion based, meaning you can get to this very good level if you attempt all the calculations, you do all the work, and you put in effort. And really the exemplary, the top notch, is when you've really made very few mistakes, and you've really taken it to the next level. There you go. There's the conclusion of lesson 2. Okay, so lesson 3. So lesson 3 is the concept map. Is a lesson for students building concept map. So they're going to be creating this for Newton's second law, and like I said, this is really the big idea here in this unit. Lesson 2 was kind of like the big project, but the big idea is Newton's second law. And it does get confusing. I do throw a lot, this unit does have a lot of kind of definitions and technical words that I kind of throw at these students. So this is just a way for them to help remember their ideas and help connect them. So again, here you can see the rubric, and you can see I have a category for completion, accuracy, visuals, and format. So accuracy, as you can see, is only one component of what I'm looking for. And here we go. Here's an example of this concept map. So yeah, here they go. They start off with Newton's second law, and they say what it depends on, and what that is. Is it a vector? Is it a scalar? The units. So they have this concept map going here. Okay, so here's my unit resources page, and this is just links that the students can use during their assignments and for reference while they're trying to complete these tasks that I've given them. Some you can see, like the egg drop simulator and the car crash simulator and the web quest, have been linked elsewhere, but some, for example, Newton's second law, haven't. So this is just like an alternate way for students to get the information if they don't want to use their book, or if the book isn't clear. And here we have the assessment for the unit. So these are this is assessment timeline, and this will this shows the timeline of how we're doing things. And you can see here that we start this the egg drop early on, but it's not till the final when it's actually graded. And then we have the rubric, and we have a peer evaluation for the egg drop device. Alright guys, that's my unit. I hope you liked it.